Hey guys, tonight we're exploring a story that everyone in history should know. The story is, how did the Romans make water flow uphill? You get comfortable, take a moment, like the video, and subscribe. But only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. How did the Romans make water flow uphill? The Roman search for water. Imagine yourself standing on a quiet hillside just before sunrise. The air is cool, carrying the scent of damp earth and wild grass. Somewhere nearby, you hear the gentle sound of water moving over smooth stones. It is not a great river, nor a roaring waterfall. It is only a small spring, quietly emerging from the ground, as it has done for countless generations. At first glance, it seems ordinary. Yet for the people of ancient Rome, a spring like this could determine whether an entire city would flourish or disappear. Water shaped every part of Roman life. It was present in the busiest streets, in peaceful gardens, in crowded bathhouses, inside private homes, and beneath the paving stones where hidden channels carried it from place to place. Long before anyone turned a tap or heard the hum of an electric pump, the Romans had already built one of the greatest water systems the world had ever seen. Even today, many people look at the remains of Roman aqueducts and wonder if they somehow discovered a way to make water flow uphill. The tall stone arches stretching across valleys seem almost magical. Looking at them from a distance, it is easy to imagine that the water climbed mountains before descending into cities. For centuries, stories have suggested that the Romans possessed mysterious engineering secrets that later generations forgot. The truth is no less remarkable than the legend. The Romans never forced water to ignore nature. Instead, they understood nature so well that they persuaded it to work entirely in their favor. Their greatest invention was not a powerful machine. It was patience, observation, careful measurement, and an extraordinary respect for the quiet force of gravity. To understand how they accomplished this, it helps to forget the modern world for a little while. Imagine living in a city with no electric pumps, no plastic pipes, no steel reservoirs, and no treatment plants. Every drop of clean water must come directly from nature. If that supply fails, everything else begins to fail as well. In ancient Rome, water meant survival. Families needed it for drinking and cooking. Bakers depended on it to prepare dough before dawn. Farmers relied upon it to irrigate crops during dry seasons. Builders mixed it with lime and volcanic ash to create the concrete that still amazes engineers today. Blacksmiths cooled glowing iron with it. Doctors washed wounds with it. Public fountains offered it freely to travelers who crossed busy streets under the Mediterranean sun. Perhaps nowhere was water more closely connected to daily life than in the famous Roman baths. These enormous public buildings welcomed thousands of visitors every day. They were places to bathe, exercise, study, meet friends, discuss politics, conduct business, or simply escape the heat. Their pools remained constantly supplied with fresh water, while used water flowed away through carefully designed drains. Such a system required an astonishing amount of planning long before the first stone was laid. Yet Rome itself did not begin with abundant water. The earliest settlement stood among hills beside the river Tiber. Although the river was valuable for transport and trade, its water was often muddy and unsafe to drink. Nearby springs provided cleaner water. But as the population grew, these local sources could no longer satisfy everyone's needs. Each new generation faced the same question. Where would tomorrow's water come from? The answer could not be found by digging deeper wells alone. Underground water was unreliable, and during dry summers many wells produced very little. Rivers could flood in winter and shrink in summer. Rainwater was unpredictable. The growing city required something more dependable. So Roman surveyors began looking beyond the city. They traveled through forests, climbed hills, crossed rocky valleys, and followed tiny streams back toward their origins. They understood something important that remains true today. Water emerging naturally from hillsides was often cleaner than water collected downstream. As rain slowly filtered through layers of rock, much of the dirt remained behind. By the time the water reached the surface again, it was cool, clear, and remarkably pure. Finding these hidden springs became one of the first great challenges of Roman engineering. The search demanded more than luck. Experienced surveyors learned to read the landscape with remarkable skill. Certain plants suggested damp ground. Particular rock formations hinted that underground water might be trapped beneath them. Morning mist sometimes revealed moisture hidden below the surface. Even the behavior of animals offered subtle clues. Shepherds who spent their lives wandering remote hills often knew springs unknown to anyone else. Once a promising source had been discovered, the real work began. The Romans could not simply collect the water in buckets forever. Their cities were growing too quickly. Entire communities depended upon a continuous supply that never stopped flowing day or night, through every season of the year. This required careful measurement unlike anything many people had attempted before. Imagine holding a shallow bowl filled almost to the edge. If you tilt it only slightly, the water begins to move. Tilt it too much, and it rushes forward, spilling over the edge. Keep it perfectly level, and nothing happens at all. Roman engineers realized that the landscape behaved in much the same way. Water did not need steep slopes. In fact, steep slopes often created dangerous problems. Water moving too quickly could damage channels, erode stone, and create turbulence that carried sediment downstream. The ideal path was surprisingly gentle. Sometimes the water descended only a few centimeters over hundreds of meters. Achieving such precision without lasers, satellites, computers, or digital instruments seems almost unbelievable today. Yet Roman engineers developed specialized tools that allowed them to measure tiny differences in height across long distances. Their work required extraordinary patience. A single mistake early in the route might prevent water from reaching the city many kilometers away. Each measurement mattered. Each adjustment mattered. Every stone mattered. Slowly, almost quietly, an invisible road for water began to appear across the countryside. Contrary to popular belief, those magnificent aqueduct bridges were only a small part of the entire system. Most Roman aqueducts remained hidden from view. They passed beneath fields, through hillsides, inside covered channels, and across gentle slopes where travelers might never notice them. The towering arches survived because they were dramatic, but they represented only those rare places where valleys interrupted an otherwise carefully descending route. This surprises many visitors today. Standing beneath the soaring arches of a Roman aqueduct, It is easy to imagine that the entire structure stretched across the landscape in the same way. In reality, most of the journey took place underground, protected from sunlight, storms, animals, and contamination. Keeping the channels covered also reduced evaporation beneath the hot Mediterranean sun. Leaves, dust, and wildlife found it more difficult to enter the water. Maintenance workers could inspect sections through carefully placed access points, while the system continued serving the city beyond. Little by little, the Romans transformed geography itself into a quiet partner. They did not command water, they guided it, and that simple difference explains why their achievements have endured for nearly 2,000 years. The greatest Roman engineers were never trying to defeat gravity, they were listening to it. As the first light of morning spreads across the hills, imagine those surveyors standing silently beside another newly discovered spring. Before them lies a journey that may stretch for dozens of miles. Valleys, ridges, forests, and rocky ground stand between this peaceful hillside and the bustling streets of Rome. Most people would see only obstacles. The Romans saw a path waiting to be measured, and that path would eventually become one of the greatest engineering achievements in human history. Imagine the first rays of sunlight spreading gently across the rolling hills outside ancient Rome. A quiet breeze moves through the cypress trees, and somewhere in the distance, a small spring continues its endless journey from deep beneath the earth. The water does not hurry. It does not struggle. It simply follows the path that nature has prepared for it. For the Romans, this quiet movement held one of the greatest lessons in engineering. Many centuries later, people would stand beneath towering aqueducts and wonder whether the Romans had somehow discovered a way to make water flow uphill. The question sounds almost magical, as though they possessed knowledge that disappeared with the ancient world. It is an idea that captures the imagination because even today, those immense stone structures inspire awe. Yet the true secret was not hidden inside mysterious machines or forgotten formulas. It was hidden in something so ordinary that most people rarely stop to think about it: gravity. The Romans understood that gravity never rests. It never grows tired. It asks for no payment and requires no maintenance. Every single moment it quietly pulls water toward lower ground. Instead of trying to fight that invisible force, Roman engineers designed every part of their water system so gravity could do all of the work. At first, this may sound almost too simple. If gravity always pulls water downhill, then how could Roman aqueducts cross deep valleys, disappear into hills, and arrive at cities that often seemed much higher than the countryside around them? The answer begins with changing the way we imagine the landscape. When people look toward distant hills, their eyes naturally focus on the tallest points. Mountains appear enormous. Valleys seem impossibly deep. From a distance, the land looks uneven and dramatic. But water does not see the world that way. Water notices only one thing. Is the next point slightly lower than the last? If the answer is yes, then the journey continues. Imagine placing a marble on a long wooden board. Even if one end of the board is only a tiny fraction lower than the other, the marble will eventually begin to roll. It does not require a steep slope. It needs only a gentle difference in height. Water behaves in much the same way. The Romans discovered that the perfect aqueduct did not descend rapidly. In fact, if the slope became too steep, serious problems appeared. Fast-moving water could wear away stone surfaces. It could damage joints between blocks. It could stir up sand and gravel from the bottom of the channel. Over many years, those small problems could become dangerous. Instead, engineers aimed for something almost unbelievably gentle. In many places, an aqueduct dropped only a few meters over several kilometers. To modernize, that seems impossible to measure without advanced equipment. Yet Roman surveyors accomplished it using patience, experience, and carefully designed instruments. Their profession demanded remarkable concentration. Imagine walking across open countryside carrying measuring tools made from wood, bronze, and carefully stretched cords. Every few hundred steps you stop, you check the level again. You compare the height with the previous marker. Then you move forward another short distance before repeating the entire process, day after day, week after week, sometimes month after month. An aqueduct could not simply take the shortest route. It had to take the smartest route. If a mountain stood directly ahead, digging a tunnel might be easier than climbing over its peak. If a broad valley interrupted the landscape, perhaps a bridge would maintain the gentle downward slope. If solid rock proved too difficult to cut, the route might curve around the hillside instead. This explains why Roman aqueducts often traveled much farther than a straight line between their source and destination. Efficiency did not always mean speed. Efficiency meant preserving the perfect gradient. Every decision served that single purpose. Modern engineers often describe this gradient using precise mathematical measurements, but Roman builders developed practical methods based on observation long before modern science introduced today's terminology. They trusted careful measurement more than guesswork. One of their most valuable tools was known as the chorobates. Although simple in appearance, it represented an extraordinary achievement for its time. Picture a long wooden beam supported by sturdy legs. Along its top stretched a perfectly straight surface. From each end hung plumb lines, their weighted tips pointing directly toward the earth. If the lines matched carefully marked reference points, the surveyor knew the beam was level. On windy days when moving air caused the plumb lines to sway, another clever solution appeared. A shallow groove carved into the top of the beam could be filled with water. Because the surface of still water naturally becomes level, it provided another reliable guide. Nature itself became part of the measuring instrument. Once again, the Romans allowed natural forces to assist them instead of resisting them. Imagine standing beside one of these surveyors. There are no engines nearby, no electric screens, no satellite signals, only quiet concentration. The surveyor kneels beside the instrument, waiting patiently for the water inside the groove to become perfectly still. Every tiny ripple disappears. Only then does the measurement begin. The silence itself becomes part of the work. Such patience may seem unusual today, but Roman engineering depended upon it. A rushed measurement could affect dozens of kilometers of construction. Entire teams of workers trusted the surveyor's calculations before laying a single stone. Mistakes became increasingly expensive the farther the project progressed. This is why Roman engineering earned such respect throughout the ancient world. It was not built upon speed, it was built upon precision. As construction continued, workers shaped channels that looked surprisingly modest. Unlike the massive arches that dominate photographs today, the channels carrying the water were often quite narrow. They did not need to be enormous. The goal was steady movement rather than dramatic flow. Inside these channels, builders created smooth surfaces to reduce friction and minimize places where dirt might collect. Waterproof mortar helped seal tiny cracks, preventing valuable water from escaping into the surrounding ground. Even these details reflected careful observation. The Romans knew that every drop lost along the journey represented water that would never reach the city. Conservation mattered, especially during long, dry summers. As the water traveled kilometer after kilometer, something remarkable happened. It required almost no additional energy. There were no animals pulling machinery, no slaves turning giant wheels to force the water onward, no hidden engines beneath the stonework. Gravity performed every task continuously, every hour of every day. Winter, summer, day, night, year after year. Some Roman aqueducts continued operating for centuries with only maintenance and repairs. That quiet reliability became one of the greatest strengths of the entire system. The more closely one studies Roman engineering, the more it becomes clear that its true brilliance did not lie in overpowering nature. It lay in understanding nature so completely that very little force became necessary. This philosophy extended far beyond aqueducts. Roman roads often followed practical routes rather than perfectly straight ones. Bridges worked with the strengths of stone rather than against them. Buildings used arches to distribute weight naturally through their foundations. Again and again, Roman engineers observed how the physical world behaved before deciding how to build within it. Their greatest teacher was always the landscape itself. Imagine walking beside an aqueduct during a peaceful afternoon nearly 2,000 years ago. The channel is covered, hiding the water from view. Bird song fills the air. Farmers tend nearby fields. Children play along dusty roads without realizing that only a few steps away, fresh spring water is quietly traveling toward one of the greatest cities the world has ever known. Nothing about the scene appears dramatic. There is no rushing torrent, no roaring machinery. Only silent movement. Yet every minute, thousands upon thousands of liters continue their journey. Without interruption, without exhaustion, without complaint. It is almost easy to forget that every fountain in Rome, every public bath, every household basin, every workshop, and every garden may depend upon this gentle current flowing unseen beneath the earth. Perhaps this is why Roman aqueducts remain so fascinating today. Their greatest achievement was almost invisible. People noticed the magnificent arches because they were beautiful, but the true masterpiece was the invisible slope extending across forests, valleys, hills, and open countryside with astonishing accuracy. That hidden line was the real invention. It transformed gravity into an endless servant of the city. And as Roman engineers gained confidence in their ability to guide water across increasingly difficult landscapes, they soon encountered an obstacle unlike any they had faced before, a valley so deep that simply building taller arches would no longer be enough. Somehow, the water would need to descend into the valley and then appear to climb back up the other side. To anyone watching from below, it would look exactly as though the water had begun flowing uphill. The afternoon sun settles gently across the countryside, casting long shadows over fields of olive trees and patches of wild grass. Somewhere beyond the rolling hills, a narrow channel continues carrying cool spring water towards Rome. It has traveled for many miles already, moving so quietly that a traveler could walk beside it for hours without ever noticing its presence. The journey has been smooth, The slope has been gentle. Gravity has remained a faithful companion. Then, almost without warning, the landscape changes. The earth seems to fall away. A broad valley stretches across the land, its floor lying far below the carefully measured path of the aqueduct. Birds circle lazily above the open space while a small stream winds across the bottom, sparkling in the afternoon light. On the opposite side, another hillside rises steadily towards the horizon. For an ordinary traveler, the route is obvious. Walk down, cross the valley, climb back up. But water does not work that way. If the Romans simply allowed their channel to descend to the valley floor and then climb the opposite hill, gravity would immediately bring the journey to an end. Water cannot simply decide to climb higher than the point it has already reached. Left alone, it would collect in the lowest place and remain there. At first glance, it seems like the end of the story. Surely such obstacles made certain routes impossible. Yet the Romans refused to accept that answer. Instead, they looked more carefully. The valley itself was not the real problem. The problem was preserving the gentle downward journey from the original spring all the way to the city. Once they understood that, entirely new possibilities began to appear. Today, when visitors stand beneath the towering remains of Roman aqueducts, they often imagine those arches stretching for hundreds of miles across the countryside. The truth is far more surprising. Most aqueducts spent almost their entire journey underground. The famous bridges existed only where nature gave the builders no easier choice. The arches were not built because the Romans enjoyed creating enormous monuments. They were built because they solved a very practical problem. Imagine walking along the side of a hill while carrying a shallow bowl filled almost to the brim with water. As long as you keep the bowl nearly level, very little spills. Now imagine reaching the edge of a staircase. You could walk all the way down and then back up again. Or you could place a narrow wooden bridge across the gap and continue almost without changing height. That bridge is exactly what many Roman aqueducts became. The arches allowed the water channel to remain at nearly the same elevation while the ground dropped far below it. From a distance, the structure appears enormous, but the water itself continues following its familiar, almost invisible slope. Nothing magical has happened. Gravity is still in complete control. The bridge simply prevents the landscape from interrupting the journey. Building these bridges demand extraordinary confidence. Roman engineers understood that every stone must support the one above it. Unlike modern steel structures, stone performs best when it is compressed. It dislikes being pulled apart. The Roman arch solved this challenge beautifully. Picture two workers placing wedge-shaped stones one after another, each leaning gently against its neighbor. Finally, a single stone is fitted into the very top. This is the keystone. As soon as it settles into place, every other stone begins pushing gently against the next. Instead of collapsing, the entire arch becomes stronger. Its own weight helps keep it standing. It is one of the most elegant ideas in engineering. Even after thousands of years, many Roman arches remain standing despite earthquakes, storms, wars, and centuries of changing weather. Imagine the quiet sounds surrounding such a construction site. The steady tapping of iron tools against limestone, the scrape of ropes sliding over wooden pulleys, voices echoing softly beneath unfinished arches, oxen pulling heavy carts loaded with carefully cut blocks, dust rising gently into warm afternoon air. There are no roaring engines, only thousands of patient hands working together. Every block must fit precisely. A stone placed slightly out of position might weaken an entire section. Construction therefore moved slowly, deliberately. Each completed arch became another small victory over the challenges of the landscaping. Yet not every valley could be crossed this way. Some valleys stretched too wide. Others were far too deep. Building arches high enough would require impossible amounts of stone, labor, and time. Roman engineers needed another solution. This is where one of their most fascinating discoveries entered the story. Imagine filling a long leather tube completely with water. Now hold both ends upright. The water settles until both ends reach exactly the same level. Push one end lower. The water rises in the opposite end. This simple behavior had been observed long before anyone fully understood the mathematics behind it. The Romans recognized that water under pressure could behave in remarkable ways. Instead of constructing impossibly tall bridges, they sometimes allowed the water to travel down one side of a valley through strong pipes. As it descended, pressure increased. That pressure then pushed the water upward on the opposite side. To someone watching from the valley below, it appeared as though the water had climbed uphill. But in reality, it never rose higher than the level from which it originally descended. This system is known today as an inverted siphon. The name sounds complicated. The idea is surprisingly simple. Imagine a child sliding down one side of a playground slide. The child gains speed while descending. If another smooth slope rises immediately afterwards, that speed carries the child upward again. The child climbs part of the second hill without anyone pushing. Water behaves differently from a child, but the general idea helps us picture what happens. Gravity creates pressure during the descent. That pressure helps lift the water again. Yet there is always a limit. The water cannot rise higher than where it began unless an external force is added. No hidden Roman machine changed this rule. No secret technology defeated gravity. Nature itself supplied every part of the process. The Romans simply learned how to guide it. Constructing these pressure pipes required materials capable of withstanding tremendous force. Lead was commonly used because it could be shaped into durable pipes and sealed effectively. Stone pipes also appeared in certain regions, depending upon local resources and engineering needs. Creating leak-free joints became one of the greatest challenges. Even a tiny crack could waste valuable water while reducing pressure throughout the system. Maintenance, therefore, remained just as important as construction. Roman officials regularly inspected aqueducts. Workers removed mineral deposits that slowly accumulated inside channels. Broken stones were replaced. Damaged pipes were repaired. Vegetation growing too close to the structures was cut back before roots caused trouble. The water system never truly rested, neither did the people responsible for protecting it. As evening approaches, imagine standing beside one of these great valleys. The aqueduct disappears into the distance. Perhaps its arches glow softly beneath the golden light of the setting sun. Perhaps an underground section quietly follows the hillside beyond your view, somewhere beneath your feet, or perhaps high above your head. Fresh mountain water continues its endless journey. The city waiting far away knows nothing of the obstacles it has crossed. Citizens gather around fountains, Children splash their hands in cool water. Steam rises from warm baths. Bakers knead bread. Gardeners water flowers. All because gravity has been allowed to perform the same quiet task it has always performed. The Romans never made water flow uphill. They made the landscape appear to do so. That difference is subtle. Yet it explains why their achievements continue to inspire engineers more than 2,000 years later. The illusion was so convincing that generations who came after them believed the impossible had been accomplished. In truth, the greatest Roman secret was never hidden machinery. It was understanding. Understanding hills. Understanding stone. Understanding water. And above all, understanding that nature becomes an extraordinary partner when we stop trying to conquer it and begin learning from it. As darkness slowly settles over the countryside, another question quietly emerges. Finding the perfect route was only the beginning. How did Roman engineers measure tiny differences in height across dozens of miles without modern instruments? The answer reveals just how astonishing their patience truly was. As dawn slowly returns to the Italian countryside, the world feels calm once again. Thin ribbons of mist drift across quiet valleys. Birds begin their first songs of the morning, and countless drops of dew rest upon blades of grass. Somewhere beneath these peaceful hills, hidden springs continue releasing cool, crystal-clear water, exactly as they have for thousands of years. The springs are patient. They never hurry. Neither did the people who came here with measuring rods, plumb lines, wooden frames, and notebooks filled with careful observations. Long before the first stone of an aqueduct was laid, another kind of work had already begun. It was quieter than construction, slower than quarrying, less visible than carving arches. Yet without it, none of Rome's great water systems could ever have existed. The work of measuring. If there was one quality that separated Roman engineers from many of their neighbors, it was their willingness to spend extraordinary amounts of time preparing before they built anything at all. Modern visitors often admire the finished structures, the bridges, the tunnels, the towering arches. But the Romans themselves understood that the real achievement happened long before the first block of stone reached the construction site. It happened here, out in the open countryside, where the only sounds were flowing water, rustling leaves, and quiet conversations between surveyors studying the land. Imagine walking beside one of these teams. The group moves slowly across a hillside, stopping every few hundred steps. One man carries a long wooden instrument balanced carefully on his shoulder. Another holds measuring rods marked with precise intervals. Others record observations onto wax tablets, making sure every figure is copied correctly before moving forward. Nobody seems rushed. No one wants to be. A mistake made today might not become visible until the aqueduct reaches a city 50 miles away. By then, correcting the error could require months of additional work. So they measure, then measure again, then ask someone else to confirm the result. Patience was one of the greatest tools in Roman engineering. The landscape itself demanded such care. At first glance, two hills may appear perfectly level. Yet one may actually stand only a few centimeters higher than the other. To an ordinary traveler, that difference means nothing. To an aqueduct, it means everything. Water notices differences far too small for the human eye. Roman surveyors had to learn to notice them as well. One of the most remarkable instruments they developed was called the chorobates. Its appearance was surprisingly simple. Picture a sturdy wooden beam, perhaps 6 meters long, supported by carefully constructed legs. Along both ends hung plumb lines with small weights attached. Whenever the beam rested on firm ground, the surveyor could compare the hanging lines with carefully marked reference points. If both lines aligned perfectly, the instrument was level. If not, adjustments had to be made. Sometimes the wind made this difficult. Even the gentlest breeze could cause the hanging cords to sway. Rather than becoming frustrated, Roman engineers simply adapted. Along the top of the beam ran a shallow groove. This narrow channel could be filled with water. Everyone knew a simple truth. Still, water always settles into a perfectly level surface. When the water inside the groove became completely calm, it quietly revealed whether the beam itself was level. No mathematics needed, no complicated machinery, only careful observation. Again and again throughout Roman history, we see this same pattern. Nature was not treated as an obstacle. It became the teacher. Imagine waiting beside one of these instruments early in the morning. The surveyor has already poured water into the groove. Tiny ripples spread from one end to the other before gradually fading away. Nobody speaks. Everyone waits. Finally, the surface becomes perfectly smooth, like polished glass. Only then does the measurement begin. There is something almost peaceful about the process. No rushing, no loud commands, only quiet confidence. Over many generations, Roman surveyors became astonishingly skilled at reading the land. A distant ridgeline, the angle of a hillside, the shape of a valley, the direction of seasonal streams. All these details became clues. To most people, the countryside appeared beautiful. To Roman engineers, it also became a map. Every rise and every hollow suggested possible routes. Some pathways promised easy construction, others hinted at hidden dangers. The goal was never simply to find the shortest distance. Instead, they searched for the smoothest descent. Sometimes they meant following the natural curves of a hillside for several miles. Modern roads often cut directly through mountains using powerful machinery. Roman engineers rarely had that luxury. Instead, they learned to cooperate with the shape of the land. The result was often surprisingly elegant. An aqueduct might appear to wander. In reality, every gentle curve had a purpose. Perhaps a rocky cliff became easier to avoid. Perhaps softer ground allowed easier excavation. Perhaps maintaining the correct slope required a slight detour. Every bend represented another decision made after careful observation. Imagine looking down from above. The route does not resemble a straight line drawn with a ruler. It resembles a ribbon laid gently across the countryside, following every contour with quiet precision. This flexibility became one of Rome's greatest engineering strengths. The surveyors also understood something else. The earth itself was never completely predictable. Heavy rain could soften soil. Small landslides might alter slopes. Rivers occasionally changed course after severe flooding. Therefore, every route needed enough stability to survive not just one season, but many generations. This required experience that could not be learned from books alone. Older surveyors taught younger apprentices. The lessons passed quietly, from one generation to the next. How to recognize unstable ground, how to identify solid bedrock, how to estimate the effort required to tunnel through different kinds of stone, how morning shadows could reveal subtle changes in the landscape, invisible during midday sunlight. Knowledge accumulated slowly. Each completed aqueduct made the next one better. By the time Rome reached the height of its power, its engineers possessed centuries of practical experience. That experience became one of the empire's greatest treasures. As the survey continued, markers were placed along the chosen route. Some were simple wooden stakes. Others were small piles of carefully arranged stones. Each one represented another confirmed measurement. Another step closer to carrying water across the countryside. Imagine following these markers through forests where sunlight filters gently between tall pine trees. Across open fields where farmers pause briefly to watch the engineers at work. Along quiet hillsides where shepherds guide their flocks. Beneath wide blue skies. Every marker forms part of an invisible thread stretching from the mountain spring towards the distant city. No water flows yet, only ideas, only measurements, only possibility. Yet already the future aqueduct exists in the minds of its builders. They can almost see it, not as arches, not as stone, but as a perfectly measured path waiting to be brought into existence. There were moments when difficult decisions had to be made. Suppose the ideal route across private farmland. Would the landowner agree? Suppose another hillside contained unstable clay likely to shift after heavy rain. Would it be wiser to tunnel through solid rock instead? Every choice involved careful discussion. Roman engineering was not simply about calculation. It was also about judgment. Experience often mattered just as much as mathematics. This careful planning explains why many Roman aqueducts remained in service for centuries. Their builders were thinking far beyond their own lifetimes. They expected future generations to depend upon these channels. Children not yet born would drink this water. Cities not yet fully built would grow because of it. That sense of permanence shaped every decision. As afternoon sunlight begins warming the countryside, imagine the surveyors reaching the edge of another broad hillside. They pause once again. One engineer studies the horizon. Another checks the instrument. A third quietly records the latest figures. The route continues, steadily, patiently, always descending. Never more than necessary, never less. There is something almost poetic about such work. Thousands of tiny measurements combining into one immense achievement. No single observation appears remarkable by itself. Yet together they create a pathway capable of carrying life across entire regions. Perhaps that is the greatest lesson these Roman surveyors leave behind. Great accomplishments rarely begin with dramatic moments. More often they begin with quiet attention, a careful eye, a patient hand, a willingness to measure one more time before moving forward. Long before Rome became famous for its magnificent aqueducts, it became exceptional at something far less visible. It learned how to understand the landscape. And once that understanding had been mastered, the builders faced another challenge. Measuring the route was only the beginning. Now they had to carve channels through mountains, dig tunnels into solid rock, and build structures that could survive centuries of rain, wind, heat, and earthquakes. The real construction was finally about to begin. The morning has fully arrived now. Sunlight spreads across the hills of central Italy. warming the pale limestone cliffs and the winding paths that disappear into forests of oak and pine. Somewhere high above the valleys, a spring continues to release its clear, cool water into the carefully surveyed channel that Roman engineers have planned with such remarkable patience. The route has been chosen. Every gentle slope has been measured. Every marker has been placed. Now comes the part that demands not only intelligence, but endurance. The land itself must be shaped. For many people today, construction begins with powerful machines. Mountains are cut apart by enormous excavators. Solid rock yields to drills driven by engines. Concrete arrives in giant mixers, and steel cranes lift stones that once required hundreds of workers. The Romans knew none of these things. Their greatest machines were human determination, disciplined organization, and thousands of skilled hands working together toward a common goal. Standing at the beginning of an aqueduct project, you would not hear the roar of diesel engines. Instead, you would hear iron striking stone. The rhythmic sound echoes across the hills. Tap, tap, tap. Sometimes louder, sometimes softer, but always steady. It is the sound of progress measured not in hours, but in seasons. Imagine yourself walking toward one of these construction sites. Dust hangs gently in the warm air. Oxen pull heavy wagons loaded with freshly cut stone. Carpenters shape wooden beams with careful strokes of their axes. Stonecutters kneel beside large blocks of limestone, patiently smoothing each surface until it fits perfectly against the next. Nobody appears hurried. The builders understand something that has become increasingly rare in later centuries. A structure intended to survive for generations cannot be rushed into existence. The Romans believed that the hidden parts of a building deserved as much attention as the visible ones. An aqueduct channel might eventually disappear beneath the ground, unseen by almost everyone who benefited from it. Yet the workers still carved its walls with extraordinary care. They knew that rough surfaces slowed the movement of water. Tiny cracks could become leaks. Poorly fitted stones might allow roots to grow inside over the years. Every hidden detail mattered. This philosophy can still be seen today, wherever Roman engineering survives. Many ancient structures have lost their decorative features through weather and time. Yet their foundations remain astonishingly strong. The beauty was never only on the surface, and it was built into every layer. As construction advanced across the countryside, workers often encountered one obstacle that no survey could avoid: the mountain itself. From a distance, a hillside may seem gentle. Walk closer, however, and the reality changes. Solid rock rises before you. Steep cliffs interrupt the planned route. Massive ridges stand directly between the spring and the distant city. The easiest solution might seem obvious. Simply climb over the mountain. Yet Roman engineers knew that doing so would create another problem. Remember the gentle slope that gravity required? Climbing too high meant descending too steeply afterward. The water would begin moving too quickly. The carefully planned gradient would be lost. Instead of going over the mountain, they often chose to go through it. This decision demanded remarkable confidence. Imagine standing before a solid wall of limestone with nothing more than iron tools, wooden supports, ropes, and determination. No explosives, no electric drills, no modern tunneling equipment, only patience. The first workers marked the exact location where the tunnel should begin. Then, little by little, they started removing the stone. Each strike of the hammer produced only a small fragment. Each hour created only a little more space. Yet thousands of such hours slowly transformed the mountain itself. The tunnel advanced one step at a time. Sometimes Roman engineers attacked the mountain from both ends at once. Separate teams began digging toward one another, guided entirely by the careful measurements made earlier by the surveyors. Imagine the level of trust required. Each team could not see the other. Solid rock separated them. They relied completely upon calculations completed weeks or even months before. Would the tunnels meet? Would they pass each other unnoticed? Would one emerge higher than the other? These questions remained unanswered until the final meters disappeared. When the two passages finally connected, it represented one of the greatest moments of triumph an engineering team could experience. Not because the opening was dramatic, but because every earlier measurement had proven correct. There is something quietly inspiring about such precision. Long before computers checked calculations instantly, Roman surveyors achieved astonishing accuracy using little more than observation, geometry, and experience. Inside the tunnels, conditions were very different from the warm sunlight outside. The air became cooler. Echoes replaced birdsong. The scent of damp stone filled the narrow passage. Oil lamps flickered against rough walls, casting moving shadows across the faces of the workers. Every sound seemed louder underground. The strike of a hammer, the scrape of a shovel, the steady breathing of men who had spent hours carving through solid rock. Progress here could be painfully slow. Some days the tunnel advanced only a short distance, yet no one expected quick results. Everyone understood that permanence required patience. Ventilation also became essential. Fresh air had to reach the workers. Smoke from lamps needed somewhere to escape. To solve this, Roman engineers often dug vertical shafts from the surface down into the tunnel below. These shafts served several purposes at once. Fresh air could circulate. Spoiled rock could be lifted out more easily. Workers gained additional access points along the road. Future maintenance also became much simpler. Centuries later, inspectors could still enter parts of the aqueduct through these carefully positioned openings. Once again, Roman engineering revealed its habit of thinking far ahead. Construction was only the beginning. Maintenance was part of the original design. As the tunnel slowly reached completion, attention returned to the water channel itself. Contrary to what many imagine, Roman aqueducts were not enormous rivers flowing through stone corridors. Most channels were surprisingly modest, only large enough to carry the required amount of water while allowing maintenance workers occasional access. The channel floor received particular attention. It had to remain smooth enough for water to flow steadily without creating unnecessary turbulence. Builders coated many surfaces with a waterproof mortar made from lime mixed with volcanic ash. This remarkable material hardened even when exposed to moisture. It resisted cracking far better than many ancient building materials. Modern scientists continue studying Roman concrete because of its extraordinary durability. In some coastal structures, it has survived nearly 2,000 years despite constant exposure to seawater. The aqueduct channels benefited from the same careful understanding of materials. Imagine running your hand gently across the finished surface. It feels cool, solid, smooth. Each section joins the next almost seamlessly. There are no large gaps where precious water might disappear into the surrounding earth. Every drop remains on its intended path. As construction spread farther from the original spring, different teams often worked simultaneously along separate sections. Stonecutters prepared building blocks, laborers cleared vegetation, masons assembled retaining walls. Carpenters built temporary scaffolding. Blacksmiths repaired worn tools each evening before the next day's work began. Although thousands of people contributed, the project moved with remarkable organization. Nothing happened entirely by chance. Roman administrators understood logistics almost as well as engineering. Food had to reach workers. Fresh tools needed regular delivery. Animals required care. Stone quarries had to produce materials continuously. Even a brief interruption could delay progress for weeks. Every successful aqueduct, therefore, became not only an engineering achievement, but also a triumph of planning. As afternoon sunlight begins to soften, imagine standing near the entrance of a newly completed tunnel. The difficult work is finally finished. A gentle current of fresh spring water enters one side, quietly, patiently, without hesitation. Moments later, it emerges from the opposite end, exactly where the surveyors predicted many months before. No celebration disturbs the peaceful landscape, only satisfaction. The mountain no longer blocks the journey. Instead, it has become part of it. The water continues toward Rome, almost as though the mountain had never existed. Perhaps this is one reason Roman engineering still feels so timeless. Its greatest victories rarely appear dramatic. The structures do not shout. They simply endure, generation after generation, century after century. Even today, hikers crossing the Italian countryside sometimes discover forgotten tunnel entrances hidden beneath trees or covered with moss. Many no longer carry water. Some have partially collapsed. Others remain astonishingly intact. Each one reminds us that nearly 2,000 years ago, ordinary men with ordinary tools accomplished work that still commands admiration today. As evening slowly approaches, the sounds of construction begin to fade. Hammers fall silent. Oxen return to their shelters. Workers wash the dust from their hands before sharing a simple evening meal. Above them, the first stars appear one by one, yet the water never stops moving. It continues its quiet journey through the freshly carved tunnel, following the same gentle slope that Roman surveyors measured so carefully long before construction ever began. Tomorrow, the builders will continue farther along the route. New hills await, new valleys, new challenges, and eventually the aqueduct will approach the place where all this effort truly matters. The city itself. There the Romans faced perhaps their greatest engineering challenge of all, bringing millions of liters of fresh water into one of the busiest cities on earth, and making sure every fountain, bathhouse, garden, workshop, and household received its share. The first light of morning slowly reaches the outskirts of Rome, long before the city's streets begin to fill with merchants, craftsmen, senators, and travelers. Something else has already arrived. Fresh water. It has traveled through quiet forests where only birds witnessed its passing. It has crossed valleys on elegant stone arches. It has slipped silently through tunnels, carved deep inside hillsides. For days, sometimes even weeks, it has followed a journey planned with extraordinary patience. Now, at last, it approaches the greatest city of the ancient world. Imagine standing upon one of Rome's hills just as the sun rises above the horizon. Below you, the city slowly awakens. Smoke begins rising from kitchen fires. Bakers open heavy wooden doors. The sound of sandals echoes across stone streets. Market stalls are prepared for another busy day. From every direction, people begin moving toward fountains, workshops, temples, and public squares. Nearly every one of them will depend upon water before the morning is over. For many ancient cities, supplying enough clean water to a few thousand people was already a difficult challenge. Rome faced something almost unimaginable. By the height of the empire, its population may have reached close to 1 million people. Whether the exact number was slightly higher or lower remains a subject historians continue to discuss. But one fact is beyond doubt. No city of its time demanded more fresh water than Rome. Meeting that need every single day required far more than simply building aqueducts. The water still had to be managed, directed, protected, shared, and somehow delivered across one of the busiest urban landscapes the ancient world had ever known. As the aqueduct reached the city, the rushing mountain journey finally slowed. The Romans understood that water arriving too quickly created unnecessary pressure and turbulence. Instead, they guided it into large, settling reservoirs. Imagine entering one of these quiet chambers. The noise of the outside city becomes distant. The water flows gently into broad stone basins, where it finally has an opportunity to rest. Tiny grains of sand slowly settle towards the bottom. Small pieces of gravel sink quietly out of the current. The water grows clearer without anyone adding chemicals or using complicated machinery. Nature once again performs the hardest part of the work. The Romans simply provide enough time for it to happen. Workers regularly entered these reservoirs to remove accumulated sediment. Maintenance never truly ended. An aqueduct ignored for only a few years would slowly lose efficiency. The Romans understood that every successful system requires care long after construction finishes. From these reservoirs, the water began dividing into many different directions. Imagine the roots of a great tree spreading beneath the earth. One thick trunk gradually separates into larger branches. Those branches divide again into smaller ones. Eventually, countless tiny roots reach every corner of the surrounding ground. Rome's water network developed in much the same way. The main aqueduct carried enormous quantities of water toward the city. Inside Rome, carefully designed channels separated that flow into many individual routes. Each destination served a different purpose. Some water traveled toward magnificent public baths. Some supplied decorative fountains that sparkled beneath the Mediterranean sun. Some entered wealthy homes. Some reached military barracks. Some supported workshops where leather, cloth, and metal required constant washing. Even the city's gardens depended upon this invisible network. Every branch had been planned, every connection measured. Nothing happened by accident. Roman officials carefully decided where water should go first. Clean drinking water received the highest priority. Public fountains came next. These simple stone structures stood throughout the city, allowing ordinary citizens to collect fresh water every day without traveling great distances. Imagine approaching one just after sunrise. Already a small queue has formed. Women carrying clay jars wait patiently beside elderly neighbors. Children chatter quietly while watching clear water pour continuously from carved stone spouts. A traveler pauses to drink before continuing through the city. Nobody pumps the water, nobody turns a handle. It simply flows. Hour after hour, day after day. Gravity continues performing its silent work. These public fountains represented something remarkable. In many parts of the ancient world, obtaining clean water remained a daily struggle. In Rome, enormous numbers of people could simply walk to a nearby fountain. Fresh water became part of ordinary life. Of course, this did not mean every neighborhood received exactly the same service. The wealthiest districts often enjoyed additional private connections. Some grand houses possessed their own running water. Imagine entering the home of a prosperous Roman senator. A quiet courtyard surrounds a shallow reflecting pool. Nearby, a small fountain trickles gently into a marble basin. Servants carry fresh water directly into kitchens without leaving the property. Guests wash their hands before meals, using water that has traveled dozens of miles from distant springs. Such comforts reflected both wealth and social status. Yet even these private supplies remained carefully regulated. Water was valuable. Roman authorities kept detailed records concerning legal access to the aqueducts. Unauthorized connections sometimes appeared. Hidden pipes occasionally diverted water illegally. Inspectors regularly searched for such thefts. Punishments could be severe, not because the empire wished to appear harsh, but because every stolen drop reduced the supply available elsewhere. Water belonged to the city as much as to any individual. Perhaps nowhere demonstrated Roman confidence more clearly than the public baths. To modern visitors, the scale almost seems impossible. Imagine entering one of these enormous complexes during a peaceful afternoon. Warm sunlight filters through tall windows. Voices echo softly beneath vast, vaulted ceilings. Steam rises gently from heated pools. Some visitors exercise, others discuss politics, some read poetry. Many simply relax after long hours of work. All around them, fresh water continues arriving continuously. Cold pools, warm baths, hot bathing rooms. Every section depends upon constant movement. Old water leaves. Fresh water enters, without interruption, without mechanical pumps, only gravity. The amount of water consumed each day was astonishing, yet the aqueducts continued supplying more. Imagine the confidence this created. Roman citizens grew accustomed to abundance. Flowing fountains, clean baths, reliable drinking water. Such comforts became part of everyday expectations. Many scarcely considered the extraordinary engineering hidden beyond the city walls. That is often the fate of successful infrastructure. When it works well, people almost forget it exists. The greatest compliment an aqueduct could receive was silence. No complaints, no shortages, no interruptions. Only dependable service. Beneath the busy streets, another hidden network quietly carried away used water. Supplying clean water solved only half the problem. Wastewater also needed somewhere to go. Otherwise, disease and unpleasant smells would soon overwhelm even the greatest city. The Romans therefore built remarkable drainage systems beneath their streets. Imagine lifting one of the heavy paving stones. Below lies a carefully constructed channel leading toward larger underground sewers. Water from fountains, rain falling upon rooftops, overflow from baths. All gradually found their way through this unseen network, before eventually reaching the river Tiber. Perhaps the most famous of these structures was the Cloaca Maxima. Originally constructed centuries before the empire reached its greatest power, it remained one of the largest drainage systems of the ancient world. Even today, parts of it continue functioning after more than 2,000 years. Once again, Roman engineers demonstrated a remarkable habit. They built not only for themselves, they built for generations yet to come. As evening approaches, imagine climbing once more to one of Rome's hills. Below you, thousands of oil lamps begin glowing throughout the city. The day's heat slowly fades. Families prepare evening meals. Public baths welcome their final visitors before closing. The fountains continue flowing exactly as they did at sunrise. Nothing about them appears dramatic. No crowds gather simply to admire running water. It has become ordinary, reliable, expected, yet hidden beyond the horizon, across forests, valleys, mountains, and quiet countryside. Countless workers, surveyors, stonecutters, and engineers made this ordinary moment possible. Their greatest success was not creating something spectacular. It was creating something dependable. A city of nearly 1 million people could wake every morning confident that fresh mountain water would arrive once again. Without pumps, without electricity, without engines, only through patience, careful planning, and an extraordinary understanding of nature itself. As darkness settles gently across Rome, another question quietly waits. Water could reach the city. It could fill fountains and baths. But how did the Romans keep those long channels clean for decades and even centuries? The answer reveals an entire world of inspectors, caretakers, repair, and quiet maintenance that most people never see. Night slowly gives way to another peaceful morning. A pale golden light spreads across the Roman countryside, touching the tops of ancient pines before reaching the long stone lines of the aqueducts. Dew glistens on the grass, birds begin their quiet songs, and the water continues its endless journey toward the city, just as it did yesterday and the day before, and for countless mornings before that. To the people of Rome, this dependable flow must have seemed almost effortless. Every fountain still overflowed. Every public bath welcomed visitors. Every workshop found the water it needed. From the outside, everything appeared perfect. But hidden behind this remarkable reliability was an army of people whose names history rarely remembers. The guardians of the aqueducts. Unlike generals who won battles or emperors whose statues filled public squares, these men achieved success by making sure nothing happened at all. No broken channels, no empty fountains, no unexpected shortages. Their greatest accomplishment was that millions of Romans hardly ever thought about them. Perhaps that is one of the quiet truths of every great civilization. The most important work is often the least visible. Imagine following one of these caretakers as the first light reaches the hills outside Rome. His day begins long before most citizens awaken. He walks beside a covered section of aqueduct carrying simple tools, a small hammer, an iron scraper, a lamp, and perhaps a leather bag filled with supplies for the minor repairs. There is no sense of urgency in his steps. Instead, there is routine. He has walked this route many times before. He knows where tree roots grow close to the channel. He remembers which retaining wall required attention after the previous winter's heavy rain. He notices details that most travelers would never see. A small crack, a loose stone, water trickling where none should appear. Tiny signs often prevented enormous problems. Roman engineers understood a lesson that remains true today. It is always easier to repair a small fault than a major failure. This philosophy shaped the entire maintenance system. Rather than waiting for aqueducts to collapse, inspectors traveled continuously along the routes. Some examined bridges, others entered tunnels, teams cleaned reservoirs. Every section received attention before serious damage could develop. Imagine entering one of the inspection shafts we encountered earlier in the story. A narrow opening leads downward into the cool darkness beneath the earth. The air feels noticeably cooler than outside. Your footsteps echo softly against stone walls, polished smooth by generations of flowing water. The channel continues quietly beside you. Its surface reflects the gentle light of an oil lamp. Nothing dramatic greets the inspector, only steady movement. Yet this calm scene demands careful observation. The water itself tells a story. Is it flowing at the expected height? Has the current slowed? Does the color appear slightly cloudy? Every change may hint at something happening farther upstream. Perhaps heavy rain has carried additional sediment into the spring. Perhaps roots have entered the channel. Perhaps a section of wall has shifted ever so slightly. Experienced inspectors learn to recognize these subtle clues. The aqueduct almost speaks to them, not through words, but through small changes that only patient eyes can understand. One of the greatest challenges came from something beautifully ordinary: minerals. The spring water feeding Roman aqueducts often carried dissolved limestone and other natural minerals collected during its journey through underground rock. At first, these minerals remained completely invisible, but as years passed, tiny layers slowly settled along the inside walls of the channels. Imagine placing a kettle on a fire every day for many years. Gradually, a thin, white coating begins forming inside. The same quiet process occurred within Roman aqueducts. At first, the deposits hardly mattered. Then they became slightly thicker. Decade after decade, they slowly reduced the space available for flowing water. Left untouched long enough, they could seriously reduce the efficiency of an entire aqueduct. Fortunately, the Romans anticipated this. Workers regularly entered the channels carrying iron scrapers and chisels. Patiently, they removed the accumulated mineral layers. The work was neither glamorous nor easy. Dust filled the air. The passages were narrow. Progress came slowly. Yet every section cleaned restored the aqueduct's original capacity. It was careful maintenance rather than dramatic rebuilding. Imagine these workers kneeling inside the cool stone passage. Outside, summer heat warms the countryside. Inside, only the steady sound of flowing water accompanies the gentle scrape of iron against limestone. Hours pass quietly. Little by little, the channel becomes clean once again. When they finally emerge into daylight, few citizens in Rome will ever know the work has been done. They will simply notice that the fountains continue flowing. Nature also presented constant challenges. Storms occasionally loosened rocks on steep hillsides. Floodwaters eroded riverbanks. Strong winds toppled trees whose roots later threatened nearby structures. Even the changing seasons demanded attention. Winter rains softened certain soils. Summer heat expanded stone ever so slightly. Although Roman construction was exceptionally durable, No structure remained completely untouched by time. The caretakers therefore watched constantly. Imagine standing beneath one of the great aqueduct bridges after several days of heavy rain. The valley below is greener than usual. Water rushes through the stream beneath the arches. An inspector studies every supporting pier. Has the current removed too much soil around the foundations? Are there fresh cracks in the masonry? Has falling debris damaged the channel above? Most inspections end quietly. Everything remains secure. The bridge continues standing exactly as intended. The inspector records the observation and moves onward. This quiet consistency becomes another reason Roman aqueducts survive for centuries. Nothing is assumed. Everything is checked. Of course, not every problem came from nature. Human beings occasionally created difficulties as well. Water was valuable, very valuable. Some landowners living near an aqueduct saw an opportunity. A hidden pipe placed carefully into the channel might divert fresh water toward a private estate. Perhaps only a small amount. Surely nobody would notice. Yet if enough people thought the same way, entire neighborhoods inside Rome might experience reduced supply. Roman officials took such theft extremely seriously. Inspectors searched regularly for illegal connections, lead pipes entering the aqueduct without permission, fresh excavation near buried channels, unexpected reductions in water flow. The evidence often revealed itself to experienced eyes. Water left clues. Once discovered, illegal diversions were removed. The law protected not only the aqueduct itself, but also every citizen depending upon its water. In many ways, the Romans viewed water as a shared public trust. No individual possessed the right to endanger the city's supply for personal convenience. As the empire expanded, this philosophy spread beyond Rome itself. New aqueducts appeared across Europe, North Africa, and parts of the Middle East. Each required its own network of caretakers. Each relied upon local knowledge. Although construction methods remained similar, every landscape presented unique challenges. Mountain snowmelt behaved differently from Mediterranean springs. Desert climates demanded different maintenance from wetter northern provinces. Roman engineers adapted without abandoning their fundamental principles. Observe carefully, measure patiently, repair early, respect gravity. These simple ideas served them remarkably well. Imagine an older inspector walking beside a younger apprentice. The elder pauses beside a nearly invisible crack in a retaining wall. Most people would walk straight past it. He gently touches the stone, then quietly explains why this tiny fracture deserves attention before the next rainy season. The apprentice listens carefully. No written manual could replace such experience. Knowledge passes from one generation to another through countless ordinary conversations like this. Perhaps that is why Roman engineering remained so successful for so many centuries. It was never only about stone. It was about people willing to learn, people willing to observe, people willing to care for structures they themselves did not build. As evening slowly settles across the countryside, once again, the inspectors complete another day's journey. The channels remain clear. The bridges remain sound. The tunnels remain dry. Far away, the fountains of Rome continue their gentle flow beneath the fading light. Citizens gather water for evening meals. Children laugh beside public basins. Steam rises from the baths one final time before night. Almost no one thinks about the quiet men walking lonely paths beyond the city walls. Yet without them, the miracle of Roman water would soon become only a memory. The aqueducts endured not simply because they were brilliantly designed. They endured because generation after generation chose to protect them. And yet, despite all this remarkable care, even the greatest engineering system could not last forever. Wars would come, empires would weaken, maintenance would gradually disappear. One day, many of these once living waterways would fall silent. Their story was about to enter its most fragile chapter. The evening sky fades gently from gold to deep blue, and one by one, the lamps of Rome begin to glow. Their warm light reflects softly upon quiet fountains that have flowed without interruption for generations. Water still murmurs through marble basins. Public baths close their great doors for the night. Bakers prepare dough for tomorrow's bread, confident that fresh water will once again greet them before sunrise. It is easy to believe that such a city could continue forever. When something serves people faithfully for centuries, it begins to feel permanent. Children are born knowing the fountains. Their parents knew them. Their grandparents knew them as well. Few stop to wonder what would happen if the water ever stopped. Yet history reminds us that even the greatest achievements depend upon continuous care. Stone may last for centuries, but civilization itself is far more delicate. Imagine yourself standing beside one of Rome's great aqueducts during the 4th century. At first glance, almost nothing has changed. The arches remain magnificent. The channels still guide water with patient precision. Inspectors continue making their rounds. Engineers still understand how the system works. From the outside, Rome appears as confident as ever. But beyond the city's distant frontiers, the world is slowly changing. The Roman Empire, once expanding in every direction, now spends increasing energy protecting borders that stretch across enormous distances. Armies march not to conquer new lands, but to defend old ones. Resources that once funded ambitious construction projects gradually shift toward military needs. This change happens quietly, year after year. Most ordinary citizens scarcely notice. The fountains continue flowing. The baths remain open. Life carries on. History often changes this way, not through a single dramatic moment, but through countless, small decisions accumulating over many decades. The aqueducts themselves remain strong. The challenge lies elsewhere. They require people, inspectors, stonecutters, surveyors, administrators, laborers. Without these dedicated workers, even the finest engineering begins to weaken. Imagine an experienced caretaker retiring after 40 years of service. He knows every curve of the aqueduct, every inspection shaft, every hillside where winter rain sometimes loosens stones. His knowledge cannot simply remain behind when he leaves. Someone else must learn. Someone else must care. As long as this chain continues, the aqueduct survives. When the chain begins to break, the future becomes uncertain. Gradually, political instability makes such continuity more difficult. Different emperors rise and fall. Civil conflicts interrupt ordinary administration. Taxes become harder to collect. Some regions prosper while others struggle. None of these events immediately destroys an aqueduct, but together they slowly reduce the attention it receives. Maintenance becomes slightly less frequent. Repairs wait a little longer. Small cracks remain unrepaired through another season. Tiny problems quietly grow. Nature, always patient, notices every delay. Roots continue expanding beneath stone foundations. Mineral deposits slowly thicken inside channels. Heavy rain wears away exposed slopes. No single change appears catastrophic. Yet together they begin altering a system that once seemed unstoppable. Imagine walking beside an aqueduct that has missed several years of careful maintenance. At first, it still appears impressive. The arches stand proudly against the sky. Water still flows, but a closer look reveals subtle differences. Small plants grow from joints between stones. The channel contains more sediment than before. A retaining wall leans ever so slightly after repeated winter storms. These are not signs of failure. They are signs of neglect. There is an important difference. Failure often arrives suddenly. Neglect arrives quietly. The Romans had always understood this. That is why earlier generations invested so heavily in constant inspection. As long as someone cared, the system remained remarkably resilient. Then came periods of invasion. Over several centuries, different groups entered Roman territory, sometimes peacefully, sometimes through war. Cities changed hands. Political authority shifted. Roads became less secure. Travel itself grew more difficult in certain regions. Aqueducts, stretching for dozens of miles across open countryside, became increasingly vulnerable. Unlike city walls, they could not easily defend themselves. Imagine an army approaching Rome. The aqueduct crosses hills, valleys, and open plains long before reaching the city. A single damaged bridge. One collapsed tunnel entrance. A section of broken channel. Any of these could interrupt the flow. Throughout history, attacking an enemy's water supply has often proved easier than attacking the city itself. There were moments when invading forces deliberately damaged aqueducts to weaken Rome. The most famous examples occurred during the Gothic Wars of the 6th century. Sections of several aqueducts were cut, reducing the city's access to fresh water. It was a practical military decision. Without abundant water, daily life inside the city became far more difficult. Imagine waking one morning and discovering that the familiar sound of flowing water has disappeared. The fountain in your neighborhood stands silent. The basin where children once played lies empty. People gather around the remaining sources, uncertain when the flow might return. For generations, water had seemed endless. Now every drop becomes precious. The silence feels almost unsettling. It is important, however, not to imagine that every aqueduct vanished overnight. History is rarely so simple. Some channels continued functioning. Others received temporary repairs. Certain regions preserved Roman engineering traditions far longer than others. The decline unfolded gradually, differing from place to place. Even during difficult centuries, people recognized the value of these remarkable structures. Whenever possible, they repaired them. Sometimes old Roman stones became part of newer buildings. Sometimes abandoned channels found entirely new purposes. Nature also began reclaiming what human hands had built. Imagine returning to a once busy aqueduct, several generations after regular maintenance has ended. Wildflowers grow along its edges. Fig trees send roots into tiny cracks. Birds nest beneath the arches. The water channel, once carefully cleaned every year, now collects leaves carried by autumn winds. Rain slowly washes soil against forgotten walls. The countryside grows quieter, yet the stone remains, patient as always, waiting. Perhaps the most extraordinary part of this story is that many Roman aqueducts refused to disappear completely. Even after centuries, Without the organized maintenance that once protected them, large sections survived. Modern visitors walking through Italy, France, Spain, Turkey, Croatia, and many other countries can still stand beneath arches constructed nearly 2,000 years ago. Some continue carrying water even today, not always for the same cities, not always through the same channels, but the original engineering remains astonishingly sound. This endurance tells us something important. Roman greatness was never built solely upon ambition. It rested upon craftsmanship, stones carefully shaped, mortar carefully mixed, measurements carefully checked. When the people responsible eventually disappeared, the structures themselves continued standing as long as nature allowed. As twilight settles over the abandoned remains of one forgotten aqueduct, imagine listening carefully. The loud voices of construction crews have faded into history. The inspectors no longer walk their familiar routes. The public baths stand quiet. The great fountains no longer sparkle beneath afternoon sunlight. Only the evening breeze moves gently through empty arches. For a moment it might seem like the end of the story, but history has one final surprise. Centuries later, curious travelers, architects, engineers, and historians would begin studying these silent monuments once again. They would ask the same question that continues to fascinate people today. How did the Romans accomplish something so extraordinary without modern technology? And in searching for that answer, they would discover that Rome's greatest legacy was never simply the aqueducts themselves. It was the way their builders thought, a way of thinking that still influences engineers across the world. Why their way of thinking still shapes the modern world. As the first light of another morning slowly reaches the ancient hills surrounding Rome, the landscape feels both familiar and timeless. Gentle mist rises from the valleys. Birds welcome the new day. And somewhere beneath the earth, water still follows paths first discovered nearly 2,000 years ago. Many of the great cities of the Roman Empire have changed beyond recognition. The emperors are gone. The legions no longer march across Europe. The marketplaces speak different languages. Entire kingdoms have risen and disappeared since the last Roman engineers walked these hills. Yet the water still understands the same law it always has. Gravity has never changed. That simple truth may be the greatest reason Roman engineering continues to inspire people today. When many imagine the Romans, they often picture enormous armies, magnificent temples, marble statues, or dramatic gladiatorial contests. Those achievements certainly deserve their place in history. But there is another side of Rome that speaks far more quietly. It is the Rome of careful observation, patient planning, disciplined craftsmanship, and an extraordinary willingness to work with nature instead of trying to overpower it. Perhaps this is the greatest lesson hidden inside every surviving aqueduct. The Romans never truly made water flow uphill. They never discovered a mysterious force capable of defeating gravity. Instead, they asked a different question. How can gravity become our greatest helper? That single change in thinking transformed everything. Imagine standing beside one of the old Roman channels early in the morning. No water pumps hum nearby. No electric motors vibrate beneath the ground. No computers monitor pressure or temperature. Only silence. And within that silence, water continues moving exactly as the engineers intended centuries ago. There is something deeply comforting about such simplicity. Modern technology often impresses us because it appears complicated. Roman engineering impresses us because it often removed unnecessary complication. The fewer moving parts a system required, the fewer opportunities existed for failure. A gravity-fed aqueduct never needed fuel. It never waited for electricity. It never required someone to switch it on each morning. As long as the spring continued flowing and the channels remained clear, the journey never stopped. That idea remains surprisingly modern. Today, engineers around the world continue designing systems that depend upon natural forces whenever possible. Gravity-fed drinking water networks still serve countless towns and villages. Mountain reservoirs often deliver water without pumps. Modern drainage systems continue relying upon carefully measured slopes. Wastewater treatment plants use gravity wherever practical, because it saves enormous amounts of energy. Even many modern irrigation systems follow principles remarkably similar to those first perfected by Roman builders. Technology has advanced. Materials have improved. Computers now perform calculations in seconds. Yet the underlying idea remains familiar. Understand nature first. Design second. Imagine a young civil engineer standing beneath the remains of the Pont du Gard in southern France. Around her stand stones carefully placed nearly 20 centuries ago. The bridge has survived wars, earthquakes, floods, political revolutions, and changing civilizations. She studies the gradient, the precision, the careful distribution of weight. Although she carries advanced instruments capable of measurements beyond Roman imagination, she still recognizes the same principles: accuracy, patience, respect for natural forces. History becomes a quiet teacher. The Romans also leave another lesson that feels surprisingly relevant today. They understood maintenance. Building something impressive was never considered the end of the story. In many ways, it was only the beginning. Throughout this journey, we have followed the inspectors, walking lonely countryside paths, the workers scraping mineral deposits from narrow channels, the engineers repairing tiny cracks before they became dangerous. These quiet routines rarely appear in history books. Yet they explain why Roman aqueducts lasted so long. Civilizations often celebrate construction. The Romans also celebrated preservation. Perhaps modern societies sometimes forget this balance. New bridges receive grand opening ceremonies. New buildings attract admiration. Yet maintaining existing infrastructure often receives far less attention despite being equally important. Rome reminds us that lasting success depends not only upon creating great things, but also upon caring for them faithfully. Imagine visiting one of the surviving aqueducts on a peaceful autumn afternoon. Golden leaves drift slowly through the air. The ancient stones glow softly beneath warm sunlight. Children laugh nearby. Without fully realizing, they are playing beside one of humanity's greatest engineering achievements. Nothing about the scene feels hurried. The arches simply stand, patiently, quietly, as they have for countless generations. Many visitors ask the same question. How could people without modern technology accomplish something so extraordinary? Perhaps the better question is slightly different. How did they become so patient? The answer may lie in the Roman understanding of time itself. Many aqueducts required years or even decades to complete. The people beginning construction often knew they might never see the finished project, yet they worked carefully anyway. Each stone they placed would benefit strangers not yet born. That way of thinking demands remarkable generosity. Imagine laying the first foundation of an aqueduct knowing that your grandchildren, rather than you, might witness its completion. Would you still carve each stone with care? Would you still insist upon perfect measurements? The Romans often answered yes. Their work reached beyond individual lifetimes. Perhaps this explains why their achievements continue speaking to us across the centuries. They remind us that some of humanity's greatest accomplishments emerge slowly, one careful decision after another, one measured step after another, one patient generation teaching the next. The story of Roman water is therefore much larger than engineering alone. It is also a story about curiosity. Thousands of years ago, someone quietly observed that water always sought lower ground. Another person realized a gentle slope worked better than a steep one. Someone else discovered that still water could help measure a perfectly level surface. Generation after generation, these observations accumulated. Eventually, they produced aqueducts stretching for dozens of miles. The miracle was never a single brilliant invention. It was thousands of small insights, patiently connected together. Even today, scientific discovery often follows the same path. Rarely does one dramatic breakthrough appear from nowhere. Instead, knowledge grows slowly. Observation after observation, experiment after experiment. Question after question. Rome's engineers would likely recognize this process immediately. As the afternoon sunlight begins fading, imagine walking one final time beside an ancient aqueduct. The countryside is peaceful. Olive trees sway gently in the breeze. Swallows circle gracefully above the arches. The water, where it still flows, continues its quiet journey without asking for attention. It simply follows the path prepared for it so long ago. You remember the question that began this journey. How did the Romans make water flow uphill? Now the answer feels both simple and profound. They did not. They made the landscape appear to do so. They measured so carefully that gravity itself performed the impossible-looking task. The illusion became so convincing that people continued repeating the story for centuries. Perhaps that is the greatest compliment ever paid to Roman engineering. When ordinary understanding could no longer explain what people saw, they assumed magic. In reality, the Romans needed no magic. Only careful eyes, patient hands, thoughtful minds, and deep respect for the natural world. As evening settles once more across the hills of Italy, the ancient stones remain where generations placed them. Some aqueducts still carry water, and others stand silent beneath vines and wildflowers. Yet every surviving arch tells the same quiet story. Human greatness is not always measured by the ability to conquer nature. Sometimes it is measured by the wisdom to understand it. The Romans left behind more than stone bridges, tunnels, fountains, and channels. They left behind a way of thinking. Observe before acting, measure before building. Maintain what you create. Work with nature instead of against it. Those lessons have traveled farther than any aqueduct ever could. And perhaps, like the water that first inspired them, they will continue flowing gently into the future for many centuries still, following the ancient water routes of Rome. Imagine that the story has not quite ended. The sun rises once more over the countryside surrounding Rome. Golden light touches fields that have been cultivated for centuries. Wildflowers sway gently in the morning breeze. Birds cross the sky above ancient stone arches that have watched the seasons change for nearly 2,000 years. The Roman Empire is gone. The emperors have vanished into history. The legions no longer march. And yet somehow parts of the aqueducts remain. If you were to walk through the Roman countryside today, there are places where the ancient water routes still reveal themselves. Sometimes they appear suddenly on the horizon, a line of arches stretching across a valley. Sometimes they hide among trees, half covered by ivy and moss. Sometimes they disappear beneath modern roads before emerging once again in open fields. It is almost as if the landscape remembers. Imagine beginning a quiet morning walk along one of these ancient routes. The air feels cool. The city remains distant behind you. Ahead, the aqueduct follows the contours of the land exactly as Roman surveyors intended centuries ago. At first, the structure appears surprisingly modest. Many people expect enormous arches at every turn because those are the images most often shown in books and documentaries. Instead, much of the route is nearly invisible. The channel runs beneath the ground. A slight ridge in the earth hints at its presence. Only someone who knows where to look would recognize it. This hidden quality reveals something important. The aqueduct was never built as a monument. It was built as a tool. Its purpose was not to impress travelers. Its purpose was to carry water. The beauty came naturally from good engineering. As the path continues, you reach one of the surviving bridges. The arches rise gracefully above a shallow valley. Standing beneath them, it becomes easier to understand why generations have admired Roman construction. The stones fit together with remarkable precision. Many have endured earthquakes, storms, wars, and centuries of changing weather. They remain standing because their builder understood something fundamental. Strength does not always come from massive size. Often it comes from balance. Every stone supports the next. Every arch distributes weight carefully. Nothing is wasted, nothing is unnecessary. The structure feels calm, confident, almost timeless. Imagine placing your hand against one of the ancient blocks. The stone feels cool despite the growing warmth of the morning. Countless people have touched these surfaces before you. Travelers, farmers, soldiers, pilgrims, historians, engineers. Each generation arrives with different questions, yet most leave with the same sense of admiration. How could something built so long ago still remain? Part of the answer lies in the Roman understanding of materials. They did not always choose the easiest stone to work with. They chose the stone most suitable for the environment. In some places, durable volcanic rock became the preferred material. Elsewhere, limestone offered both strength and practicality. The choice depended upon the landscape. Again and again, Roman builders adapted to local conditions, rather than forcing every project into the same pattern. As the day grows brighter, you continue following the route. Occasionally, the modern world appears nearby. Cars move along distant roads. Buildings rise on the horizon. Electrical lines cross the countryside, yet the aqueduct remains strangely unaffected by these changes. Its purpose belonged to another age, and yet its lessons feel surprisingly modern. Imagine meeting a group of engineering students walking the same path. They carry notebooks instead of wax tablets. Their measuring tools use lasers rather than plumb lines. Their calculations are performed by computers. But as they study the aqueduct, they recognize familiar principles. Gravity, load distribution, hydraulics, maintenance planning, risk management. The language has changed, the principles have not. This may be one of the most remarkable aspects of Roman engineering. It remains understandable. A modern engineer can still look at an aqueduct and follow the reasoning behind it. Nothing depends upon mysterious knowledge. Nothing relies upon lost magic. The logic remains visible within the stone itself. Imagine reaching a section where water still flows. Not every ancient aqueduct carries water today. Many stand silent, but a few continue serving practical purposes. Here, after nearly 2,000 years, the water still moves gently through channels first designed by Roman minds. The sound is soft, peaceful, almost identical to the sound Roman citizens would have heard centuries ago. The water does not know that empires have risen and fallen. It follows the same path regardless. There is something comforting in that thought. History often feels distant. Kings and battles belong to another world. Yet water flowing through an ancient channel feels immediate, real, present. For a moment, the centuries seem smaller. Imagine sitting quietly beside the route during the afternoon. A warm breeze moves through nearby grasses. The shadows of the arches slowly lengthen. Nothing dramatic happens. The aqueduct simply exists. And perhaps that is why it continues inspiring people. Its greatness is not loud. It does not demand attention. Instead, it rewards patience. The longer you observe it, the more impressive it becomes. A traveler notices the arches. An engineer notices the gradient. A historian notices the continuity. A philosopher notices the lesson hidden beneath it all. The Romans succeeded not because they controlled nature. They succeeded because they understood it. As evening approaches, the golden light softens once more across the countryside. The ancient stones glow warmly beneath the setting sun. Birds return to their nests. The day's heat begins to fade, and the aqueduct remains exactly where generations left it, patient, silent, enduring. The people who built it could never have imagined the modern world. They could not foresee airplanes crossing the sky or satellites orbiting the earth. They could not imagine computers, electricity, or modern cities, yet they understood something timeless. Careful observation matters. Patience matters. Good design matters. And when human beings work with nature instead of against it, their creations can outlive them by centuries. The evening grows darker. The first stars appear above the hills of Italy. The ancient water routes fade gently into shadow, and with them the story of Rome's remarkable aqueducts settles into a peaceful silence. Not an ending, perhaps, but a quiet reminder that some of humanity's greatest achievements continue speaking long after their builders are gone. Where every drop ends, the night settles gently across the hills surrounding Rome. The last colors of sunset fade from the sky, leaving only the quiet glow of distant stars. A cool breeze moves softly through rows of ancient cypress trees. Somewhere nearby, hidden among the rocks, exactly as it has been for thousands of years, a small spring continues to emerge from the earth. It does not know that empires have risen. It does not know that emperors have ruled. It does not know that armies once marched across these valleys. It simply continues to flow. Perhaps that is the most beautiful ending to this story. When we first began this journey, we asked what seemed like an impossible question. How did the Romans make water flow uphill? It is a question that has fascinated travelers, historians, engineers, and curious minds for generations. The towering arches appear almost magical. The immense distances seem unbelievable. The precision feels impossible for a civilization without electricity, engines, or modern machinery. Yet now, after traveling beside the water from its hidden spring to the heart of Rome, the answer feels wonderfully simple. They never made water flow uphill. They never defeated gravity. They never discovered a forgotten force that modern science has somehow lost. Instead, they achieved something far more remarkable. They learned to understand the world exactly as it is. They realized that gravity was not an obstacle. It was their greatest partner. They discovered that careful measurement could accomplish what brute strength never could. They proved that patience often succeeds where haste fails. And perhaps most importantly, they understood that the greatest engineering begins long before the first stone is laid. It begins with observation. Imagine one final walk through the Roman countryside. The morning sun has not yet appeared. The world is almost silent. The aqueduct stretches quietly across the landscape. Its arches cast long shadows beneath the moonlight. Some sections remain hidden beneath the earth, exactly as Roman engineers intended. Others stand proudly above valleys where generations of travelers have paused to admire them. There is no crowd, no celebration, only stillness. If you listen carefully, you may hear the gentle sound of water, continuing its endless journey. The same journey it began centuries ago. The same journey countless Roman citizens depended upon every single day. Every fountain that refreshed a tired traveler. Every public bath that welcomed neighbors. Every garden that flourished beneath the Mediterranean sun. Every baker preparing bread before dawn. Every child laughing beside a marble basin. All of it depended upon this quiet current moving faithfully through stone channels built by patient hands. The Romans built roads that connected continents. They built bridges that crossed mighty rivers. They raised temples that inspired generations. But among all their achievements, the aqueducts possess a special kind of beauty. Not because they are the largest, not because they are the tallest, but because they solved an everyday problem with extraordinary wisdom. They transformed something ordinary into something timeless. Water became more than a necessity. It became proof that careful thinking could change the lives of millions. Today, engineers continue designing systems inspired by many of the same principles. Cities still rely upon gravity whenever possible. Reservoirs still collect water high above the communities they serve. Pipelines still follow carefully measured gradients. Infrastructure still depends upon regular maintenance. The tools have changed, the materials have improved, the calculations happen faster. But the philosophy remains remarkably familiar. Understand first, build second. Maintain always. That may be the greatest inheritance Rome left behind. Not merely structures of stone, but habits of thought. The willingness to measure carefully, to question assumptions, to observe patiently, to respect nature rather than challenge it unnecessarily. These lessons remain just as valuable today as they were 2,000 years ago. Imagine, for one last moment, those first Roman surveyors standing beside a quiet spring long before construction ever began. They could not see the finished aqueduct. They could not know that people thousands of years later would still admire their work. They only knew that somewhere beyond the hills stood a growing city in need of clean water. One measurement followed another. One stone followed another. One generation taught another. Slowly, almost unnoticed, one of history's greatest engineering achievements came into existence. No miracle, no magic, only patience. As dawn finally begins to brighten the eastern horizon, the countryside slowly awakens. Birds sing once again. Mist rises gently from the valleys. The spring continues its endless flow. And somewhere, carried by gravity exactly as nature intended, another drop of water begins the same quiet journey the countless drops have followed before it. It moves without haste, without noise, without asking for recognition, just as the Roman engineers once did. Perhaps that is why their work has endured for so long. The loudest achievements often fade with time. The quiet ones continue serving long after their creators are gone. So whenever you see the graceful arches of a Roman aqueduct stretching across a valley, or hear someone ask how the Romans made water flow uphill, you will know the truth. They never forced water to do the impossible. They simply understood the possible better than almost anyone who came before them. And in doing so, they left behind a lesson that flows as steadily today as it did in the ancient world. Sometimes the greatest wonders are not created by overcoming nature. Sometimes they are created by listening to it. Thank you for taking this quiet journey through the world of Roman engineering. And as the first sunlight touches the ancient stones one final time, the water continues its endless path toward the future, just as it always has.